for second step. First, you identified all the options available. For each option in option list, in the list of in the option in the viable option list. So you first check whether an option is viable. Then for each option in the viable option list, what do? You take that option. You take the option. So you take this option, let's say. You take this road and see whether after taking this road, having taken this option, is this leading, having taken option 1, is this part of the solution space leading you to a goal, to your goal. So it may lead to you to a goal, or it may not lead you to a goal. So in a recursive way, you call the same function. So take the option and call, this is the function, let's say function n. Okay, this is function n. Call the same function with n plus 1. That is, you have moved ahead for the n plus 1th step. Now you have to explore the n plus 1 step taking this option. And if this n plus 1 step is successful, so find out the result of this step. That is, you have decided to move ahead with the n plus 1th position, let's say. You are at nth position. So you have decided to take the viable option and move to the n plus 1st position and to see whether you can take n plus 1 position. Again, what is n plus 1? Same. So when you reach n plus 1, again you will obviously do the same thing. The options, find the options which are viable or available, see which are viable. Viable means which are possible to take, and then explore all the options from there, because this will call, like we are doing here, further recursion. Okay, and till you decide to return without calling the sub, till you reach the end. Okay, when no options are viable, you reach the end. Okay, then take the option. Now, if result that it is possible to proceed with this option, if result equal to true, then you return true. If result is equal true, return true. That means you have found that it is good to take this option, and continue with it because you got a positive result. So you took the correct option. Otherwise, else, if result is false, that is, this option at this moment failed. That is, you should not have taken that option which is viable, but if you follow that option, you are not going to reach your goal. That is, result is not true. Else, what do? You reverse this option, or you reverse the option, or delete the option, whatever. Reverse the option, and then that's it. And then proceed with the next option. Now it seems very logical, but it's not very trivial. Okay, now this is called backtracking. Why is it called backtracking? See here, for example, because rather here, if you observe this step, and this step is perhaps very important, you observed that I took the option, okay, blindly, not blindly. This was one of the viable options. That is, it was legitimate option to take at this stage. I took that route, or I took that option, and tried to do the sub problem now. That's why I say n plus 1. Now my problem is advanced, or you can say size of the problem has reduced, whatever way you want to look at it. So my problem has advanced, or my solution has advanced, I should say. Is the solution possible to solve at the n plus 1 stage? From the n plus 1 stage to the end, is there a solution? Can it be solved from this point onwards? If it is possible to solve it, then my option was correct. So result is true. I proceed and return true. That means my option was correct. Else, my option has failed. I should not have taken that option, though it is a viable option. So I reverse the option, and next time I'll take some other option and then see if I took that option, whether at the next level, whether I'll be able to go ahead. Okay. Then the thing is, if I'm able to succeed, then I don't have to take another option, right? In most questions. But if I fail in that route, I have to take a forward option. I have to take reverse this option, because you have already taken the option. So you may have to do something to reverse that action which you have taken, and you have to come back and repeat with the next feasible action which is viable at this point. Viable means it is possible to do it at this stage. Okay. Did anybody get it at that level? Now I'll give another. But are you understanding the basic of what backtracking is all about? Now I will try and give you a little more example, but I'm going to give you a practical example, but at a very, very fundamental level, it is like this. Okay, let me try to say it in other words. Yeah. Let's say your job is to start from location A and reach location H, let's say, or some location Y. Okay. Your job is to start from A and reach Y. And then there are many routes. Okay. Now there are many roads which can go. Now you are looking at A. You don't know what is going to happen later. So let's say the route for you is route R1, route R2, route R3. And let's say each route is going to take some money from you. So first thing is, each route has a cost associated with it. Let's say C1, C2, C3. Now at this stage, first of all, you have to see which route among these routes are viable. Is every route viable? For that, you may have a wallet in which there is money M. Okay. If C1 is greater than M, M is the money that you have in your wallet. If C1 is greater than M, then obviously this route is not viable, isn't it? The route may be taking you to the goal which you don't know, but there is no point in going on this route because you don't have money to reach that, to take that route itself, because C1 is greater than M. M is the amount of money that is there in your wallet. So if you have M dollars with you and this route is going to cost you C1 then it's not a viable route. So you can straight away discard this search space. So if you compare this with brute force will go in all routes. Here you are being a little circumspect, little more smart, and you are able to discard certain portion of this tree which is useless to go, because you're not going to travel in this route. It is just not viable. Okay. Now let's say C2 is less than M, C3 is also less than M. So it is viable for you to reach these points. Let's call these points some C and D. Okay. This B is not possible. B may lead to Y for all you know. There may be a route from B to Y which is beyond your capacity to explore, having been at A. Now the routes which are possible for you are the routes which go through C and D. Now you don't know whether you should go the C way or D way. Both are viable because C2 is less than M and C3 is also less than M. You can choose to go either way, C way or D way. But what will you do? Now you have no other criteria in front of you at this stage to decide whether you should go the C way or the D way. Both are viable. So what will you do? So you will explore first the C way. Okay. And then now run the same algorithm. So you will say take option C. Okay. The viable options are C and D. Take option C and see whether this route which has now A and C in it. Initially it had only A, and which has a destination, sorry, the route which is a combination of A and C, okay, and your goal is still Y, okay, and the money that you have now with you, because you have chosen to take this, is M minus C2. Whether this route is viable, this is the same function which you called here originally, okay. Now this route initially was called only with A, now it is, the route is called with A and C. That means what nodes you have already visited, you have put there in A and C. Why? Your goal has not changed. This is your goal. This is your route so far, or your visited points so far. And the money which you have now is this, right? So money has reduced because you took this route. So the amount of money you can spend from C to reach Y is reduced by this, because you took that route which cost you C2. And if this route returns result, if this route is feasible, then you have got a route AC, whatever, so it returns a feasible route also, or it may use a global variable to give that. So if result is equal failure, if it is success, then you can return success. Okay, I'm not looking at that, or decide to do whatever you have to do. But if it is a failure, then what will you do? What will you have to do is, you will now say, I have to retrace option C. That is, this I have to not. So I say reverse C, which will mean, reversing C will mean bringing back my money to M, because I have not decided to take this, I'm going back. So now my money wallet is restored to M, and also my result set is now just A, not AC. My visited set is now A only, not AC. And now you have to write the outer loop, which will loop through options C and D. Now you have tried C. Next time you will try option D, because you are going to loop through all the viable options at this stage. So now next time you go through this, you will not take option C, you will take option D, the same loop. So I should say probably option equal to C and reverse equal to C. Then next time you say, I will say option equal to D, and now your thing will be A, D, Y. A goal will be the same, M minus C3, because now the money you have is M minus C3. If that is feasible, you say reverse. If it is feasible, then you don't have to reverse, you just go ahead and return success. If it is not feasible, then you have to say return failure, because you have tried all the routes. So outside the loop, once you have tried, so once you have exited from this loop and you have not reached the destination, you have to say return false, because you are not able to return true from any of the viable routes. So you say return false. Okay. So this is in essence what we have to do. Yeah. So are we ready to look at now the backtracking? We are. Okay. So this is in principle what is backtracking. Now there is a similar principle. So if you okay, before I go out of this, backtracking uses recursion with an assumption. So you make an assumption. This is what I meant by saying option first. Okay, before that, you look for whatever are viable options. Once you decide what are the viable options, take one of the viable options, see whether you are able to proceed with the solution, see for the result value. If it gives you success, very good, you don't have to reverse it. If it doesn't give you the result value, then you have to reverse that option that you took and carry on with the next option which is available at this stage, which is viable. So that in short is the way we can proceed. Okay. So so there is this whole principle of how to proceed with the backtracking. Okay. Now I'll give you a little bit concrete example of how backtracking proceeds, and then I will give you a little more pseudocode. I'll show you a little more pseudocode, and then you will write some code and we'll come back. Okay. So this 2 days we'll do a bit of backtracking. Okay. So let me now give you a little more insight with a real problem of pseudocode. Okay. Yeah. Okay. So let me now proceed to the next stage. Okay. So now we will take the 4 queens problem. This is a classic problem used to explain 4 queens problem. It is just a derivative of the 8 queens problem. Okay. So 4 queens is you have a board of 4 instead of chessboard of 8, and you have to place a queen in place 4 queens. Place 4 queens. So imagine a smaller truncated chessboard. Imagine a smaller truncated chessboard, and you have to put 4 queens, obviously one in each column, such that the queens don't attack each other. So you have to put 4 queens on a chessboard such that all queens are safe. All queens are safe from each other. This is the question. So this is a classic example of backtracking. Now I am assuming that everybody knows that much of chess to understand what a queen means. So queen can move horizontally, vertically, and diagonally. It cannot move like a knight, the 2.5 square. It cannot do, but it can move horizontally, vertically, and diagonally. Everybody knows that, no? Everybody has played that much chess at least. Yes? Yeah. So if you have not played that much chess, then I don't know what to do. Then you should not be in this class, right? So yeah, so every queen can move horizontally. For those of you who are completely new, horizontally is like this, vertically is like this, diagonally is like this. It can kill anybody in any of these directions. Okay. So now, how do you proceed with this, and how does this how does this become a backtracking problem? Okay. So how do we start? We start with column equal to 1. So we will go column wise. You can also do row wise, but traditionally it is done column wise. So I am proceeding to do it column wise. So I am in column 1. Now in column 1, all positions of queen are viable because there is no queen which is on the left. So initially my options are, these are my various houses in a particular column. I can take row 1, row 2, row 3, row 4. These are all viable options in column 1, right? I can take any one of these options. I can decide to put, it's a 4 column, 4 by 4 board. So I can take row 1, row 2, row 3, row 4, anyone. All are available for column 1. Okay, let's pretend that, so options are R1, R2, R3. So let's pretend that the choice was made of R1 for column 1. So row 1 was where in column 1 we decided to put the first queen. Now, then we move to the second iteration of this function. Okay, we have chosen R1 here. Remember, R1 itself may be wrong, but we have chosen R1 here. Okay, and so from the original solution space, let's put it 0. I have chosen R1. Now, if I choose R1 here, what are the viable options for this column? What are the viable options for column 2? So I cannot, row 1 is not a viable option, correct? Because if I put another queen in row 1, this queen will destroy it, right? I cannot put a queen here also in column 2. I am now on column 2, please. I am here. I am discussing column 2. I cannot put a queen here because the queen will be attacked diagonally by the previous queen. So this is not a safe position. So the safe positions for the queen in column 2 are this and this. I can choose either one of them. These are the only two safe positions. So I will say the safe viable positions, we call viable positions, are R3 and R4. Only these two. These two are possible to use. Okay, R1, R2 is ruled out. So I will not investigate that. Only safe position. So before I take any option, I will say whether it is possible, feasible to take that or not. So let's say I decide to take R3. Let's say I decide to take R3. No particular, I don't know. I can take any one. So I decided to take R3. I have put one more queen in R3. Okay, so I have decided to take that. Now I have come to, so column 2, I have taken R3 as my choice. Okay, now I am on column 3. That is the third recursion of my algorithm. So I chose column 2 and now I am recursing the same algorithm. Now the viable states for R3 are, see, this I can't do, this I can't do because it will be hit by this I can't do, and this I can't do. If you notice, there is not a single viable situation for this queen, correct? For any column. So this is a failure. So the fact that R3 I took as my option has resulted in a failure. So I have to backtrack. That means I have to reverse the decision of having taken R3 itself. But what are the options having taken this one? I have to take R4. So if I take R4, let's explore now. The queen is here. Queen is here now, not here. Okay. So queen is here. Now I explore R4 option. Let me draw it here. So in R4, no, not R4. Sorry, column 3. What are the options possible? Can I take this? I can't. Can I take this? Yes, I can, right? So this is possible. So R2 is possible and R3 is not possible, R4. So there is only one viable position which I can take for column 3. So column 3 is R2. So I take this queen. So this is R4 and R2. Okay, now only viable position was R2. So there is nothing more to explore in column 3 because if it fails, I have to just go back, right? So now I am here. Now I have to decide whether I can take any viable position in, now I have reached column 4 of my solution, okay, of my attempt to solve. Column 4, if I take, then in column 4, can I keep a queen here? No, because this queen will destroy it. Can I keep a queen here? No. Can I keep queen here? No. Can I keep queen here? No. None of these are all failures. R2, it's column 4 for choice of R2 is all failure. It's failure. So this is also failure. You see that return back is failure. So in R1, R3 has returned in failure. R4 has also returned in failure. Okay, by their own recursion going forward, they have all reached failure. So now what should I do? Okay, now I have to go back to R1 and return a failure here. R1 itself is a failure. That is, this was itself a failure. Now I have to go with first column. I have to choose. Now I had 4 options: R1, R2, R3, R4. So now I have to choose some other option, which is R2. Okay, the next viable option for column 1, I can take any option without any check. I can take R2. Okay, so now if I decide to take R2, okay, for column 0, okay, or first choice itself R2. So I have to draw it again. I think you are getting a hang. I don't know whether I have to do it. Let me just do it once and then I'll stop. Okay, so I have decided to take, let me change the color now. So I have decided to put a queen here. Okay. So I have decided to put a queen here because R1 is not viable. I got failure. So now viable position, another viable position is R2. If R2 is viable, that is the choice for column 1. Okay. Now column 2, what are my choices? Column 2, I can't take this. I can't take this. I can't take this. I can take this. I can take R4. Here only R4 is a viable choice for column 2. Okay. So I will take R4. That is the only viable choice for column 2. If there is only one viable choice, you have to go with that only. What else will you do? So having taken R4, okay, having taken R4, now I am in column 3. I have decided R2 here and R4 here. Now I have to decide which are viable columns in, which are viable rows in column 3. Is this row viable? Yes. So R1 is a viable row. R1 is viable. R2 obviously is not viable. R3 is not viable because this guy will hit it. R4 is also not viable. It can be attacked by this or by this. R4 is not. Again, I have only choice 1 for R3. For column 3, which is R1. Okay. So I have only R1. So I'll put a queen here. Now, having taken R1 as my choice here, I am going to column 4. Okay. Now, in column 4, I have to choose a position of the queen such that it is not in attack by anybody. Is this a safe position? No. Is this a safe position? No. Is this a safe position? Yes. Is this a safe position? No. So this is the only safe position. So I take that R3. Now I have exhausted, I have reached column 4. So I have reached the end of the solution. I can return. So I now have a viable solution, which is as shown here. Is this the viable solution? Okay. So now you have understood the 4 queens, but more important, you have to understand that I take a tentative step forward, check whether I can succeed with that. If not, I have to come back and reverse the solution. That is, I have to undo what I did and continue with the next option, right? So that is the essence of 4 queens or 8 queens. It doesn't matter whether it's a 4 queens or a 8 queens problem. They're all solution is the same. Okay. Now I'm going to show you the code. So have you understood what is 4 queens and backtracking here? Do you understand the backtrack? The backtrack is the going back and then again starting from beginning. Okay. Starting from that step till where you are going back. Okay. So now now I will show you the code for a backtrack. Please don't copy the code or don't take photos of the screen and do such nefarious activities. Then we'll ask you to do backtrack and see whether you're able to do it, and then we'll ask you to do one more which is very similar, which is a very important idea of backtrack. And these are all, first I'm going to talk about classic problems, and then we are going to do other problems which possibly are going to explore whether you have understood backtrack or not. Okay. So I'm going to do a couple of classic problems before we take you there, because you have to get familiar. So I'm now going to show you how do you write code for backtrack. Now, unfortunately, I can't get it in one side. Okay. So let us see how do you do it. So there is a class called solvenq. Okay. There is a, okay, let me first familiarize you with the data structure and how it gets called and all that. So this is main. So main is not doing anything. It's just instantiating a object and doing one of the solution of the 8-pin problem is, okay. And it's calling this method called obj.solvenq. Okay. Don't worry about it. Or why don't I, okay, let me not do this way. Let me use Geek for Geeks to show you the same thing. Okay. So this is the pseudocode of, I'll walk you through, then you do it. Okay. You will do it. We'll just enable that question and you can do it. Okay. So start in the leftmost column, that is call equal to 0. Okay. Then if all queens are placed, so you need to maintain a data structure which indicates how many queens are left to be placed and how many queens are placed already, how many are left to be placed. Okay, that means you have to go till fourth column. You have to identify where you will end. So in this case, depending on if it's an 8-column keyboard, 8-column chessboard, columns are numbered from 0 to 7. Then if you have reached, you have finished 7 columns and you have reached 8, then you are done. Okay. So if you have reached 8th column, you are done. If it's a 8-column chessboard, you are done. Now imagine you have not reached the 8th column. Try all the rows in the current column. So all rows in the current column means viable, but he's checking the viable here. So if the queen can be, so try all the rows in the current column, do the following for, okay, okay, for every tried row, do following for every tried row. If the queen can be placed in this row, now for every column, try whether you can place a queen in that row, that is it safe? If the queen can be placed safely in this row, then mark this row column as part of the solution and recursively check if placing the queen here leads to the solution. That is, you should proceed with the next column. So that is, you have to take the question into the next column. If placing the queen in row column leads, you have decided to place the queen in that column, leads to a solution, then return. So try that. If it returns a success, return true. If placing the queen doesn't lead to a solution, placing the queen in that particular row doesn't lead to a solution, then unmark this row. So if you have marked this row in finding a solution, unmark it. That is called the classic backtrack. And go to step A, where you have to pick now another row which is safe. This row is not going to get you anywhere for this column, and return false to trigger backtrack. Okay. This is what you have to do. And if all rows have been tried and nothing worked, return false to trigger backtracking. That means another option has to be taken up. Okay, now let me show you the code nevertheless. Yeah, this is some kind of pseudocode. Okay, if find solutions n. Okay, okay, let me try and explain and see whether you get it here. I don't like giving code straight away. Okay, so find solution. I find a solution. So n is the column in which you are. Okay, and other parameters is what is your last column that you have to reach, or you don't need other parameters. Okay, we found a solution. Now found a solution is what? If call equal 8, if you are doing with 8, if n, rather if you say n equal 8, you are solving for the nth column, let's say. If n equal 8, we'll say found a solution. So your condition for finding a solution 8. Then solution found, if somebody is asking you to keep track of how many solutions are possible, solution found +1, display the solution. and if solution found is greater than what the target is, then exit 0. So done. So this is if somebody is asking you to find n number of solutions. But this is your classic backtrack. This is the backtrack, right? So for value first to last, so you are seeing in this case from row 1 to row n, if is valid, that particular row for this particular column, if it is valid, if this particular row for this particular column, here value is from row 1 to row n, if is valid means is it safe? How will you decide something is safe? You have to look at the queens on your left. What all queens have been placed on the left, you have marked them, right? So if you have marked them, you have to see whether there is an attack or not. So you have to write an is safe code to check whether you are really safe in this row, in this column. This is the column, this is the row. So is this a safe position? Because if it is not safe, then it's in attack by the previous queen. So if you have, let's say you are on the 5th column and you have already placed queens in the 4th column. Otherwise, how did you reach the 5th column? So to watch what are viable rows in this column, you have to see if none of these rows or none of these positions, suppose you want to see this position should not be in attack. That is, this row in this column should not be in attack by any of these people. So you have to check, you have to write some code. It's easy to check. So because you know the positions where the queens are, it should be easy to check this. So once you have checked this, that you are, once you have checked that these positions are viable, okay, what you need to do is that you see what are the viable positions, and then you go to the next apply value. Okay, you go to apply value, and if you see this apply value, you will realize that now you have to apply the value. That means you have to occupy this row and this column. This is the row, this column. So here I should say perhaps occupy. Okay, you may be seeing on your screen or you may not be, but this screen, this position is occupied. Now continue with find solution. Do the recursion now with n plus 1, column plus 1, and perhaps you don't need other column, other parameters. And if you are able to find this, and if this gives you true, return true, and you are done, or you have found the solution. Otherwise, if you are not able to proceed, then remove the value, because this row position was choice. So unmark the position, and now proceed with the next position of this row for a given column. Okay, so that's how you'll have to do it. Okay, so you'll have to go column by column and track it. Now you'll have to first build the chessboard with zeros everywhere. So I will now step back. What Nagireddy, will they be able to do at this stage? Nagireddy Garu.
Sir, you explain the solution. You might
not there. Taking rest. Okay.
How to give
so I think you can do it. You can try.
You can
and so I'm enabling the first question, which is the